Let us just extend the previous problem a bit. Previously it was A has to be followed by a B. Now let us say every A has to be followed by BB. So after every A there should be BB. Now let us write a language. See, the language says that if there is a it has to be followed by BB. There is even a case that there can be no A at all, right? Or there can be no A at all. There can be no A at all, so on. Now if there is any A, it has to be followed by BB. If there is any A, it has to be followed by BB, so on. Infinite language. But let's try if we can give finite automata or not. So first thing is epsilon has to be accepted, therefore initial state equal to final state, and if I see any A, it has to be followed by B. I am going to accept it. It is nothing but if A is B, if there is any A, I am going to, and I have to accept only if it is followed by BB. What are the other cases? A can be followed by AA, or A can be followed by BA, or A can be followed by AB. So all these cases I have to reject. So now I have to distinguish between these three cases. One is A is followed by BB, other is A is followed by AA or BA or BB. Now if A is followed by A, I have to reject it, or I have to kill all such strings. Therefore this is going to act as a dead state. If A is followed by a I don't care what comes after it, which means these two cases, this case and this case is taken care. If A is followed by A, I don't care what comes after it. If A is followed by A, I should not accept it, even if it is A or B. Therefore this single transition is going to act as, it is going to kill all the strings where A is followed by A. Now what if A is followed by B? See this? If A is followed by B, yes, I am going to accept. But if A is followed by BA, which means if A is followed by B and then A, I am going to kill it. A has to be always followed by BB, so that I will accept it. If A is being followed by A, or if A is being followed by BA, I am going to kill it. Right? Now what about the initial state? Is it complete? We have shown what happens on A, but we didn't show what happens on B. What happens on B? Any number of B's, I should be accepting it, right? Why? Because if it contains epsilon or if it contains only B's, it is going to accept it. Now is this one complete? Yes, we have shown what happens on A, what happens on B. Is this one complete? Yes, we have shown what happens on A, what happens on B, but this one is not complete. What if I see an A after A followed by 2 B's? Again, even that A has to be followed by 2 B's. Therefore even if I see an A, I have to come back and again check if it is followed by BB or not. If it is not being followed by BB, then it will have to go to this one or this one, right? So again the checking has to be done. What if I see if A followed by 2 B's followed by any number of B's? A followed by 2 B's followed by any number of B's is also A followed by 2 B's. Therefore I had to accept it. Try to understand this. What each state is doing here, or what is the relevance of each state is, obviously E is the dead state here. The reason is once you reach it, you will never be able to go back. And the next one is whenever I have seen 0 A's, which means it can be epsilon or only B's, I am going to accept it. Now A, whenever it sees as A, we are going to B. B is going to remember that we have seen 1 A, and next thing is it should see BB in order to reach D, right? So B is going to remember that it has seen 1 A. So this B is going to remember one thing, that it has seen 1 A. And C is going to remember that after A it has seen 1 B, which means A is followed by B. And D will accept, D is an accepting state which will accept a string only if it contains, when it contains A, it has to be followed by 2 B's. If it again gets a, we have to again wait for 2 B's. Any number of B's, it is not a problem because it is still A followed by 2 B's. right, and E is the dead state.